2, 3, number 12, is that what you said?
2.3, yeah, the pitchfork quiz. This one?
Well, this one?
Thank you.
So you guys look at number 12. Jim, you
Corbin.
should know. Corbin, there you are. Yeah, that's right. Thank you. If you didn't get your quiz back, you can come up here. Now, the thing about this is it's in the freaking linear section, right? If I remember correctly. So most of these you're not going to have to classify because it's in the section, right? You know I'm going to put on the test some that you're going to have to classify yourself. I'll tell you this. I'll go ahead and tell you this. I'm going to have a collection of problems, and I'm going to say use each of these methods once. Linear, exact. You guys with me? So I'm not going to tell you which is which, but I am going to tell you there's a linear, there's a homogeneous. You guys kind of with me? So at least I'm going to give you that much help, right? Only one of each. Does that make sense? Okay. Why is that linear very quickly? All the y shit is just to a first power, and they're not multiplying each other, so they don't become some weird pseudo higher power. Is that all right? So like if I have y dy dx, that's not really anything squared, but it's sort of this weird higher power in a different way. It's two things related to y that are multiplying each other. I don't know if that makes sense. Okay.
Yeah.
What's the very first thing I need to do? In fact, linear. The minute you identify it as linear, what are you looking for? What do you have to determine so you can do the very first step? P of x. What form does it have to be in to figure out what P of x is? Yeah, the dy dx basically has to be no coefficient, right? Okay. So it'd be like dy dx plus shit y equals shit, right? Maybe not the same shit. So, let's see. I don't like overhead that you got me. I think I'm going to make that happen. Paper. Paper. There we go. So, let's see. So if I divide by 1 plus x. Now real quick, what happens over here? So I've taken this and I've divided by 1 plus x. Does anything happen here?
Pull up the x.
Damn straight. That kicks a lot of ass, right? Already I know what value of x I have to throw out, correct? What could x not be? I can already see this. If I ask you for the interval on which this has a solution, you know it can't include -1, correct? Okay. For two reasons. P of x is undefined at -1, but even at the original way it was written, the dy dx would be 0. It wouldn't be there. It wouldn't even be a dE if x was -1. Okay. Now, the next thing I'm noticing as I'm grading homework is you gotta be really careful about the negative shit, right? So what is P of x? Yeah, -x over 1 plus x. Right? So then when I go to find the integrating factor, it's going to be, how do I set that up? E to the integral? Sweet. So that can become its own, like, side quest, right? You kind of forget about the main quest. You work on the side quest. Is this maybe where anybody had trouble? Can you guys, yes? Okay. Now watch this. This is the way I like to look at this problem. If only the damn thing was flipped, does everybody agree it would be easy as shit? If it was x plus 1 over x, that would be easy as shit, yes? The way I can make that happen, so if the bottom was a single term, that integral would be easy. It's not that, Jeff, so why are we even saying this? I'm going to use m substitution instead of u, because the mu and the u apparently really confuses the hell out of me. I love it. I really want you guys to be with me on this. I'm going to let m, what do I wish was a single term?
1 plus x.
The bottom. So I'm going to let the bottom equal m and see what it does for me. Are there other ways to do this? Yeah, of course. Are some of them quicker? Maybe, I don't care. If I let m equal 1 plus x, what's dm?
What?
1 dx. And what's x? M minus 1. So what does this become then? Yeah, it'll become negative m minus 1. I could even move the negative out front, but it doesn't really matter. It just becomes 1 minus m. Is that cool? Over, oh, sorry, m. You guys can tell me if you can't see what the hell I'm writing. I know you can't read what the hell I'm writing, just want you to be able to see it. Is everybody with me on that? See the negative? It made this flip. Is that right? You guys all with me? Did anybody do it this way? Just me? I'm a weirdo? Okay. You did? Okay. Because now this is relatively easy to do because I can just break it up, right? So that'll be e to the ln m. We don't worry about c, of course, because we're just picking c to be the easiest thing that could make it. How can I rewrite this?
M minus e to the m.
No. So what's e to the ln m?
Yeah.
M. I'm going to drop the absolute value.
Oh,
It's related to picking c to be the number that makes it positive. So m e to the negative m. Let me stop from there. Is that all right? Because it'd be e to the ln m times e to the negative m. Okay. You guys all with me? This is why it's so important to show your work. Because if you make a little mistake on this, it's going to throw everything else off. And I normally, if I can find where you made the mistake, that's going to determine how many points you lose, not you got the problem wrong, so minus 20 or something crazy, right? So the less work you show, the more chance you're going to lose 20 points, because I'm not going to know what the hell happened. Okay. What does this tell me to do? By the way, what was m? Let me bring that back, because I got to make it back to x, right? What was m? 1 plus x, right? So this is 1 plus x, e to the negative 1 plus x. So what do I do with this thing? Multiply, good, because this is the whole idea. It's the integrating factor. It's the factor I multiply by to make the integration happen. So, I do this. I'm going to show you, because it sucks to have to rewrite so many times. That's what I'm going to multiply both sides by, correct? So I'm going to write the other side first. It would be x times 1 plus x e to the negative 1 plus x. I'm going to multiply both sides by this. So I'm going to get that on this side. This side, it's going to become d what?
D all that.
D all that. Y. Okay. So now the next exciting part of this is integrating this. Right? What does this feel like it's probably going to be? Say again? Yes, it's going to be by parts. I love it. I'll do this side. Let me correct myself up. And now this is just where you have to do. And again, anytime you have a polynomial coefficient of something, especially e, it could be either one, easy going, right? This is going to disappear after a few derivatives, so I let that be my u. So this might be a couple steps of by parts, right? So again, this is a really good example of, and I'm not going to give you like 8 problems, each of them has 5 steps or something, you know, like I need you to understand, this is taking a while, do you agree? So I wouldn't give you like, every problem involves this much stuff. I can't, we only have so much time to do this test. But I might give you one. Because I got to check to make sure you kind of keep track of what's going on. So did anybody get here and weren't able to continue? I mean, the by parts on this is going to be, you know, that's, how do you feel when you realize you have to buy 2 by parts? Can somebody tell me? What are your emotions at that point? Huh? Verbally? So normally what I like to do is if I'm going to give you a by parts, I'm not going to give you a by parts that has multiple steps. I'm not going to give you a by parts that involves you adding something over, get the same thing. That's, you know, you've gone through that shit. I'm going to give you enough so I can tell, do you still remember how to do by parts, the basics? So I would give you one that would involve 1 by parts at most. Just to make sure you remember the basics. This thing's got a couple. Right? So if you want to, we can spend our time on doing that by parts. I'm cool with it. Or I could just say, if you get to that point, by parts, and you're almost done with the problem, right? Is that all right? Did anybody get to that point and kind of like go, maybe if I don't finish, you won't notice. I had somebody, real quick, I think it was my Calc 2 class or whatever, that said, yeah, Mr. Wall, I heard somebody told me that you sometimes miss when students don't do problems. I'm like, I'm grading the shit out of your homework. You don't tell me that. You don't say, yeah, let's see if this guy notices I didn't do number 7. I'm going to notice the hell out of you. All right. If that's okay, if anybody wants to see that, maybe I can do that at the end if we have time. Otherwise, that's sort of like, now it's just by parts, a couple by parts. So let's do this. I gave out last time something that had, did I give that out? I gave it out a while back. That's got all the various types of differentiation, differential equations in chapter 2.
Yes.
Right? So let's look at Bernoulli's real quick. Yeah. So this one's kind of nifty. So that looks great, right? What is that so far? That's just linear. And then I do this. So that's Bernoulli's. And just to remind you guys, by the way, as a teacher, I'm making shit up. As a student, you're doing whatever the shit I give you, you made up shit. This is an equation that happens in physics, just from observations. This is what we get. So I always want to remind students as you're in a math class, yeah, some of this is contrived, right? Okay, once I tell my algebra students, only in algebra would you have somebody buy 60 cantaloupes and nobody seems to be concerned about this person, right? So very often the problems can be sort of contrived, they're made up, I'm just trying to get you to use the process. But just remember, this is an actual equation that comes out of just observations we have made so we can solve to figure out what the shit's going on. This is not purely just, and trust me, there's a huge part of mathematics that's just like play. Just theoretical, just at the moment doesn't mean shit in the real world. 20 years later, somebody will go, oh yeah, that shit you were playing with, that actually works here. That's the way it always happens. So anyway, sorry. Big side note. So what we do in this situation, remember if n equals 0 or 1, that reduces down to linear. Is that cool? Maybe even separable, right? So really it's all about when n is not 0 or 1. What do we do? And what we end up doing is we end up using this substitution. We got that right? Yeah. U equals y to the 1 minus n. Now again, a lot of what we do is built on the backs of a lot of trial and error and a lot of just, trying stuff, seeing what happens. this is not really obvious that it's going to help us, right? And instead of doing this all theoretically, let's just do a concrete example. Yes? Right off the bat, because today, review day, we ain't got much time. Okay. Because I could do this theoretically and plug shit in, but my God, it becomes a nightmare to kind of keep track of it all. So let's do a actual problem. Yeah, does this one work out okay? Yeah, sort of. Yeah. Now this one's interesting because, do you notice this is separable?
Mm-hmm.
Do you notice this is, what else about it? What other kind of DE is this? I heard it. Autonomous. Is it linear?
No.
Hell no, right? Negative 1/2 power on the y, yes? Okay. So we're going to solve this using Bernoulli's. So what is n in this case? Negative 1/2. So I'm going to use the substitution u equals y to the 1 minus negative 1/2. So what's u equal to then? That's crazy. Now, do you all agree with me that it would be so much better if I had y equals, because then I could figure out what dy dx directly and substitute? This is all just substitution. This is a substitution method. You with me? It's sort of like u sub by parts. It's just worse. But what could I do, obviously, to get a function of y, a function of u instead? Solve that thing for y. What do you get? Solve it for y. What do you get?
2/3.
Yeah, you do the 2 things. So then what's dy dx?
2/3.
Good. Let me stop for a minute. So everybody's semi with me. Let me stop. Are you guys decent with that? So it's all predicated on n. Right? If I have too many y, if I have y to the n, and it's not nice, it doesn't make it flow into a linear or some parabola or whatever. In this case it is, I know, but we're just forcing it. I use Bernoulli's, and Bernoulli's is all predicated on what's the power on that stupid extra y term, right? In this case it was a negative 1/2. Now watch what happens. I'm going to start subbing stuff in, right? dy dx is all this mess here, yes? So I'm going to replace this. What's y? U to the 2/3. So this will be u to the well, if I raise something with powers to power and multiply powers, right? So what's negative 1/2 times 2/3? Negative 1/3, right? So what Bernoulli's does is it will always take that original DE and it will make it become linear. Linear in u, and I can solve that, and at the end, I just replace u with what the hell it was. You guys got it with me? And again, that's exactly how almost every substitution method we have works. This is just another substitution method. So why is this not linear at the moment? As a coefficient, right? So if I multiply everything by 3/2 u to the 1/3, is that cool? You guys with me? If I multiply by 3/2 u to the 1/3, this goes away. This becomes 3/2, that becomes a whole u. Aw. And this just becomes 3/2. Okay. And now that's linear, right? Okay, I like it. And then I would do, now you can tell, this is one of your favorite methods ever because all that work we did has now uncovered a linear. Now you got to do the linear stuff. How does linear work?
P of x.
P of x. What's the P of x?
3 halves.
3 halves. Why is it all that? That would be just e to the 3 halves x is equal. So this would be the integrating factor. So it would be d u e to the 3 halves x equals, and I have to multiply this by this side too. Oops. That's
Boom, boom.
the x was downstairs. And that's not that bad, right? You guys see that? Yeah? Yeah.
What did we what was the term we multiplied everything by again?
E to the 3 halves x. Right? The u, the integrating factor.
Oh, it started the step before to get
Oh.
rid of, to make it
Oh,
linear.
just all the shit that's in front. I need du dx to be by itself.
Okay.
So I just multiply by what would kill that first term, right? So what would kill the 2/3? Multiply by 3 halves. What would kill the u negative 1/3? Multiply by u to the positive 1/3. Is it me? I'm sorry, is that the part? So all I'm doing is killing this shit. I don't like him. He looks bad. So I multiply by 3 halves and then multiply by u to the positive 1/3. That kills this, makes it 1. Why do I do that? Because I know it's supposed to be linear. So this would become d this after I multiply both sides by the integrating factor. And now this I have to integrate. This joke never gets old. Here I do that side. But that side, come on, how do you integrate this? E to that? Because it has exactly the chain rule piece, right? You guys with me? If I differentiate that, I get exactly that, so that's exactly what it is. So, very often with integration, you can put what you think the answer is roughly, and then you can adjust it. That's what I like to do instead of doing u sub everywhere. I just cut it in half if it's supposed to not have a 2 there, whatever. But this is perfect. I can divide by the e business. And then what was u?
1 and 2 3.
Yeah, y to the 3 halves, right? Now you could square both sides and take a cube root, but that's bullshit. Just leave it like this. You guys kind of with me? Very often, in fact, just never. If you have to take a square root, just don't. It doesn't help anything. Because you have to put a plus or minus then. It's just as explanatory to leave it implicit than it is to try to force something. Now, if there's simple stuff you can do that. But don't do something that's going to make it have a plus or minus or something. There's no need. Okay. Is that all right? We could do another one if you want to, or we can, let's do this. Anytime you guys have a specific question, bring it up. If I see nobody raising hands, I'm just going to keep going backwards. Yeah.
How do you know which one to use for homogeneous? Is it the y equals us or is it the x equals?
Oh.
Or does it not matter?
Now, the funny thing about that, real quick, there's 2 choices for homogeneous. I'll go with the way you said it. It's either y equals ux or x equals v y. The u and v doesn't mean shit. We know that. That's just I could use a box if I want. It don't just be the symbol. We use u and v, right? If you make it x over y versus y over x, that's the big consideration, right? In fact, let me see. Well, that's the next thing I want to do. Let's do some homogeneous stuff. Sounds like we're going to drink milk. Let's see. Let me pick one out of here. Oh man, I need my glasses. Do any of these look interesting? So let's see. Like, okay, number 6, real quick. I can't remember if I signed this or not, but oh well. In fact, any of these. Come back. Is this homogeneous? Number 6.
Yeah.
Yes.
Yes.
How do you tell? How did people tell so quickly? Because what's another kind of like way to phrase homogeneous? Yeah, the same degree.
Same degree.
Every term is kind of like the same degree, correct? And they all have a degree of what in number 6? 2. I love it. So that's a very quick way to tell if it is homogeneous or homogeneous. Could it be something else also? Shit, yes, right? So that's the trick, is if you have time, you try to tell, is there another form it's in that's easier? Obviously, what do you always check for first? If it's freaking separable, because that's math 180, right? Can you guys tell, is number 6 separable?
No.
I'm sorry, I keep pointing there, because that's, I'm never gonna stop doing that, I'm sorry. I'm just not used to having so many freaking screens, it's crazy. So number 6, everybody agree that is totally not separable, right?
Wait, can you say what homogeneous is one more time? Like, definition of?
The official definition involves,
No, like, simplified.
the simplified version is, every term has got to have the same degree.
Okay.
So since x is multiplying by y in one term, that counts as a second degree.
Real quick, what does degree mean? It's the total number of letters I see in a term. So in this term, I see 2 y's, that's the second degree. In this term, I see a y and an x, that's 2 variables, that's second degree. It just is a quick degree, just tells me how quickly something's gonna grow. So if I let y be something, this is gonna grow quadratic, it's gonna grow like a crab. If I let y and x vary the same way, it's also gonna grow like a square. You guys see, so that's the rough idea of how quickly is this thing gonna grow, is what degree means.
So in terms of different terms, there's different terms between them if there's like a plus or a minus, right? That's the way you think?
Oh, sure, of course, yeah. What separates terms, pluses and minuses? Yeah, okay. Like it. Now, another way to look at homogeneous, let me show you this. This is the way I looked at it as a student. And there's a really good example, I think, on the practice test, if I remember correctly. But if I can rewrite this so I get a function of y over x or x over y. So how would I get a function of y over x? What could I divide by?
Squared.
So if I divide everything by x squared, don't I get this? No, dx. You got it, buddy. Plus dy. You guys agree? If I divide everything by x squared, I get that. If I can write it in terms of y over x, as if that was the variable. That's the only variable in there, you agree, y over x. I'm not counting the derivative stuff, but you guys with me? Then I can let u equal y over x. That kind of makes a little intuitive sense. And this could be somebody just playing around. Oh yeah, I could do that. Let's let u equal y over x and just see what happens. Now I don't know if that's the actual history of it. In fact, I kind of know it isn't, but some should actually happen that way. I don't know if you guys are with me now. You don't have to do this, but this is really smart. And there's one problem on the test that you could look at as homogeneous or something else. We'll talk about the practice test. We'll talk about that in a minute. Yeah. I'm sorry. Yeah.
So you just divided everything by x squared by that. So you
Yes.
can-
Now I could have divided everything by y squared
Okay,
and gotten x over y, and that's the v option.
okay.
And of course, the letter doesn't mean shit, right? There's
Yeah.
nothing magic about v. Yeah, okay.
Should still be minus dy, right?
Oh, I'm sorry. No, I'm looking at number 6.
Oh,
My little paper went shooting up.
Oh, okay.
Now let's see, real quick. If I let u equal y over x, right? In fact, what you can do for yourself, let me see. Do you all agree I could write this like this? Let's see. Yeah, I have to make it negative, it's too bad for me. Is that cool?
Yeah.
Yes. Subtract the dy, divide by dx, put the negative on the other side, is that all right?
Yeah.
So if u is y over x, y is ux, yes? You guys with me? And then it's just a question of what's dy dx, and I can replace it, yes? The way that most substitution methods work. Let me stop for a minute. There is more than one way to do this, but this is the way I sort of fall back on. You could leave it in this form and just figure out what dy is by itself. You could do a total derivative. Let me see if you guys like that better, because you're all looking like I'm horrible. What if I left it like this? Here's y. What's dy?
udx plus xd.
udx plus
xdu.
xdu. I love it. Is that alright? You guys with me? So let's just see what happens. So what does this become? This piece.
U squared plus
You did u squared plus u dx plus dy. What was dy?
udx
udx
xdu.
plus xdu. I love it. Get out of your book. Sure. Drop on the floor, baby. Okay. So really quickly, I want this to make some sense. You can imagine before this was invented, I just kind of realized, oh yeah, I could make y over x kind of like the variable. So what if I try a u sub? So then you just see what are the consequences of that u sub. This piece should feel very familiar. It's exactly what we do when we do u sub. It's just kind of like the next level up from it. I don't know if you guys are with me or not. If I make a u substitution, that means that all my stuff is going to have to be in terms of u now, not y. So I've got to see what are the what does all the y stuff become? I know y becomes ux. What does dy become? I have to make a full substitution. When you first learn u sub, you had to take all your x shit and make it become u shit. If there's any x stuff left, it wasn't a u sub. Or you didn't do something right. Are you guys kind of with me? Same idea here. When I make when I make any kind of substitution, I need to make it a complete substitution. I cannot have any y stuff left. Y should not exist for me anymore at that moment. I've got everything in terms of u now. Equals 0 still. Do I have any like terms here? Sort of. Yeah, these can kind of go together. So I get u squared plus 2u dx plus x du. And here's the beautiful thing about this is that, what form is that in? Separable. Right? So then you separate it. Now, the one bad thing about this, I guess, how would I separate that? What would it become?
U over x and dx.
So I could do like negative 1 over x dx, is that cool? Something's going to be negative, right? So take that side over, and then this side will be
du over x.
du over u squared plus 2u. What method I'm going to have to use on this? Yes, right. Everybody's favorite. Yes. Yeah, when you make that, in fact, let me see, does somebody have that? Let me make sure I wrote down everything. Blah, blah, blah. Yeah, okay, good. I want to make sure I wrote that. So just like it says on the handout I gave you, and this is the thing you have to do for yourself. There's always two levels to these things in mathematics. Do you understand the process, and do you know when to apply the process, right? So if I were you studying, I would make sure that I understand homogeneous. I understand that by itself. And what does it mean to understand it? What are the steps to do, and what does it take it to? So many of these processes we use takes a DE and puts it into a certain other form. For example, Bernoulli's takes that thing and makes it linear. So if I know that going in, I know what to expect, and I can tell when I've made a mistake. Bernoulli's must always make it linear. Maybe separable sometimes, like we saw with one problem, right? That could sort of happen in certain. Are you guys kind of with me? Homogeneous, if I make that substitution, u equals x over y, or v equals x, u equals y over x, v equals x over y, it's going to make it become separable, which kicks so much ass. Right? So it's a little gross at the beginning. I don't know if you guys agree with me. It's a little gross at the beginning, but what's nice about it is there's a light at the end of the tunnel. You're going to get a nice separable thing at the end. Yeah.
Okay, again about the homogeneous, no matter what we pick, we still end up with the same intervals.
I could have very easily picked the x over y here, correct?
Yeah.
I would end up with the same answer. Now what's funny is, same answer sometimes means it looks very different. but it would reduce down to the other answer, right? Very often, you'll get an extra constant, but it'll just get sucked into whatever plus C is out there, right? So they would be equivalent. So when I grade these things, I have to know ahead of time, well, what would the answer look like if they did it this way or that way, right? You with me? You guys all with me? So whenever you have a choice, homogeneous, basically you always have a choice. There's never one way that's going to work and the other one isn't. Sometimes one way will be easier for one reason or another, but almost always it doesn't matter. You make it x over y or y over x. You guys know with me? Did I need to rewrite it as y over x? No. I just have to identify as being homogeneous, and then I can do all the work. I guess they're all with me. Some of you guys feel depressed. It's part of my job as a math teacher. Okay. Just to show you semi-quickly here, if I would have left this, what was it to begin with? Oh, here we go. No, that's not it. Where did I put it? Shoot. Oh, I lost it. Darn it. Yeah, okay. Well, yeah, you don't have to do the y over x. You don't need to. Oh, it was number 6, right? Yes. If you left it like this, I can tell it's homogeneous right now. I can make this substitution, get all my dy business right, and just plug stuff in. It would still get you to the same place. Just I noticed that if you solve for y over x already, it kind of eliminates a lot of kind of simplification work you have to do once you plug stuff in, but you don't need to. You can do it right off the bat. You can tell this is homogeneous. How do you know? Every term has the same degree.
Wait, is
Cool.
this a degree?
Sorry.
What?
X squared dy.
You tricked
I didn't mean to. I tricked myself too. I love it. I just want to write it down real quick. So just to let you know, you don't have to make y over x show up. If you identify as homogeneous, you can immediately make the substitution, throw stuff in, go to town. As a student, I just remember I liked getting y over x or x over y. It just made things a little simpler after that substitution. You don't have to. So let's take this step back to exact was before that, right? Let me tell you this. I'm gonna put a bonus question down about the integrating factor, for example. So if you want to get that down, you can do that bonus problem, you can get some extra points. So I always put bonus problems on my tests. So you could get a total of 6 points added to your grade if you get all 3 of my bonus problems right. You with me? They are going to be difficult. So I'm much more interested in if you're able to do a basic exact. I might ask you a question like, is this exact? And the answer might be no, and then the bonus would say, do that one anyway. So you have to do it. You have to do an integrating factor, right? I don't care that much about the integrating factor. It's good to know they exist. There are a lot of methods beyond what we're going to talk about that involve integrating factors, and they always have the exact same idea. What's kind of missing? And I showed you that concrete example where we started one where we took a total derivative and then I divided by stuff, so I made it missing. Then it wasn't exact anymore because it didn't match up. I don't know if you guys remember what I'm talking about. If you do a differential and then you divide by stuff, you've lost information. That's what the integrating factor does. It says, oh shit, what was there before? Let me give it to you. Now you can attack what's there. I don't know if that makes any sense. Okay. How do you guys feel about exact? I think most of you have done at least some problems out of the exact section. What does the answer to an exact look like? Yes, good. So whenever you figure out f is, don't just say f equals this function. You have to take that and equal it to c. That's the answer. I love it. Also, whenever you figure out what c is, don't just circle that shit. Tell me what the answer is. Right? Put c back in. I like it. So let's see. Let me pull one out of here, one out. Does anything look interesting to you? This is the time to ask me a question about a homework problem that gave you trouble. This is the exact section. Anything look interesting to you? We could also do the one on the practice test if you want, but I got that answer key. Yes.
You said from the practice, we can ask it from the practice.
Yeah, totally.
Number 5.
Let's see. I think I can shoot. I gave all mine away. Let's see. Oh, here it is. Okay, here. Number 5. Yeah. What form is number 5 in?
That looks like Bernoulli's one.
Totally. So yeah, we could do another Bernoulli's if you want to. It's up to you guys. What's N in this? In fact, I mean, how do you tell it's Bernoulli's? You can tell very quickly it's Bernoulli's. Y to the 4. So it's not linear. It's a huge example. It looks like it wants to be linear, poor little dude, but it ain't. So one little substitution will make it become linear in a different variable, in that variable u. So n, of course, is 4. So what's my substitution I'm going to make? And then u equals y to the negative 3. So that means y equals u to the? Beautiful. This is where people make really simple mistakes. You got to be careful. We all know the opposite of cubing is cube rooting. And so from this, you can figure out what dy is. dy dx in this case. So I need this to make sense. Wherever I see a y, I know what to put there, yeah? So I can make all my y stuff become u, but I got a dy dx. I can't have any y related shit left. Everything has to be replaced by u to make a de and u.
Why are you allowed to do dy dx? There's no x involved in that.
U is known to be a function of x, because it's a function of a function of x. Does that make sense? Y is a function of x in this. Do you guys agree? Yes. U is a function of y, which is a function of x, therefore u is a function of x. So if I know y is u to the negative 1/3, I can take its derivative. It's going to be a chain rule, right? Does that make sense? That's a good question, but yeah. How would I take that derivative then? Look, you bothered me. So if y equals u to the negative 1/3, what's dy du? I'm sorry, dy dx? Yeah, negative 1/3, u to the negative 4/3, du dx. So now you have everything that was y defined in terms of u. So you can plug all that stuff in, and then you got that dE to worry about. That dE will be infinitely better than this one, because I can't do shit to that one, right? It's not linear. I can't do anything with it. Maybe. Oh my God, some of you look at me like, this guy's going to start making sense any second. I haven't lost hope. All right. So you would put this entire thing in for this. I would, well, it doesn't really matter. At some point you want to divide by that x squared, right? Yeah. And then you got, this can go in for y in these two places, right? So it's just like any substitution method. I don't want to say that because, I mean, 180 substitution methods are easier because they don't have the level of complexity we're at now, but it's the same idea. It's trying to accomplish the same thing. I can't do it when it's in terms of y. So let me make it in terms of some other function. Maybe it'll work. That's basically all u sub is. Any kind of any substitution method. No, yes? You want to, again, I've worked this out, so I'm going to give you the answer key in a minute. Does anyone wanna try these? Now, let me just open it up. Does anyone have any specific questions? Did you try any from the practice test? Are you having any trouble with anything from the homework? You can ask specific questions like, I don't understand step 3 on number 17, part B. Or you can say, how the shit does linear work again? Wide range of possible questions on why.
For 2.4 over 30, I got through proving that they were exact, or proving that they weren't exact, then changed so that they were exact. But I was really struggling with the integrating with it, if you can go over it.
Oh, it tells you.
Yeah, so then multiply it in, and then you make it so that it's exact, but I was messing up some of
Okay.
that integrating.
Okay, so this one's, I wouldn't give you one like this, but this is one I could give you because it already tells you what the integrating factor has to be, and that's normally the worst part about if it's exact but not exact yet. If it wants to be exact, is what I'm trying to say. So yeah, once you multiply by this, in fact, does anyone? Well, let's see. Let's not go there yet. Make this a little. Whoops. Shit. There we go. So it's going to be x squared plus 2xy minus y squared times, or let's just put it over x plus y squared dx plus y squared plus 2xy minus x squared over x plus y squared dy equals 0. Okay. So you already did the partial y and x and showed that those are equal?
Yeah.
Okay. Of course, if you haven't tried this problem out yet, I don't know if this is when I signed in the textbook or not. That part's going to be a little funky, but you'll get there, right? You have to do my versus nx. What is m, by the way? Yeah, the first one's m. In front of the dx is what we call m. And again, on some level, m and n doesn't matter which is which. Just keep them the same so you keep it straight. So if you do my and you do nx, they have to be equal for it to be exact. This is exact, so then what's the next thing I try to do? I have to integrate this with respect to x, right? And does that look like something you really want to do? No. Well, let's see. Okay, what could we do with this? Let's look at this by itself. So I'm going to focus on this. So I need to integrate considering x is the variable, y is a constant, right? Okay. So this is where you hit the roadblock, right? Any suggestions on what we could try to do?
We add y squared on top and subtract y squared on top, and then.
Alright, this is an excellent idea. If only the damn y up top was plus, do you agree with me that would be beautiful? That would be almost too beautiful to believe, because then they would just cancel, correct? Because that's when you fold x plus y. So of course I'm not going to give you that, damn it. One thing you could try to do is to make the bottom show up on the top, which is what Yusuf was saying. If I add y squared, which is what I wish was up there, and this is the funny thing about this, like Indiana Jones in the statue. So if you add y squared, you better at the same time take y squared away. Okay, so you balance things, the bowler doesn't come, yeah.
Did you not factor the top to be x plus y, x minus y?
That wouldn't work because then the middle term would cancel. And I don't have that. So that's not factorable. The top is not currently factorable. At least not nice. You could use quadratic formula. You guys know that? Oh, yeah. Do you want to?
Yes.
Okay, good. I don't want to either.
I would.
So let's see. The only idea I have out there right now is to do this, which is actually exactly what I was considering trying to do, but I don't know if that's going to be the thing that works.
What?
Do you all agree with me that this is the same as that?
No.
Oh, yeah.
Yes. What's y squared minus 2y squared? Minus
Okay.
y squared. So if I add y squared and subtract another y squared, I actually didn't do anything. You guys remember completing the square?
Yeah.
You add 4, you gotta subtract 4, blah, blah, blah. Same damn thing, right? So on one level, it's, the math is looking at it as like, okay, human, great job, human. You did nothing. But we reorganize this shit, is what that does. Doesn't the first 3 terms become the bottom? They cancel? So let's see, can I do this? This becomes 1 minus 2y squared over x plus y squared. Keeping in mind that x is the only true variable, yes? Can you integrate this now? And if you want to, on the side, you can rewrite it letting y be 1. Just so it's easier for your brain to kind of latch onto it. Does that make sense? As long as you come back and put y back in, you can make it a constant, let your brain go latch on, and go, oh, I know what that shit is, and then come back and put the y back in. Does that make any sense? What would you get? So what would 1 over x plus 1 squared, how would that integrate? Does anybody? Yeah, it's just, it'll be like x plus y to the, so right now it's x plus y to the negative 2, correct? So the x plus y to the negative 1, you just got to make sure the constants work out and so forth. You guys semi with me? So again, what I'm saying is, there's not a damn thing wrong. First off, I'll do the first part. Look at me go. All right, sorry. If I just take this and let y be 1 for a minute, isn't this? Isn't the inside linear slope 1? Whenever the inside is linear slope 1, it's just like frickin' x. Yes? Differentiation, integration is just going to be the same thing as x. So how do I integrate x to the negative 2?
Add 1 to the power and then.
So it'll be negative x to the negative 1. So this will be negative 2x plus 1 to the negative 1. And then you just put the y stuff back in. I don't know if you guys are with me. How do I integrate x to the negative 2?
Add 1, then divide by the new power.
So it'll be negative x to the negative 1, correct? So what's the integral of 2x plus 1 to negative 2? It'll be negative 2x plus 1 to the negative 1. Exactly the same. If the inside is linear slope 1, it acts as if it was just x. Of course it does, because what would chain rule say? Say, I don't know. It wouldn't do shit to me, right? I don't know if you guys are with me or not. Sure.
Yeah, I don't know how you got from y to 1.
So the integral of this
It's just a substitution, because y is just a constant.
would be this to the negative 1.
Yes.
It's just the power rule, yes?
Yeah.
Add 1, divide by the new power, yes? So what's the integral of this then? I just throw y's in there, right? So there's going to be a y here, there's going to be a y squared in there. So it's going to be minus 2y, x plus y to the negative 1. If I could just write, everybody would be happy. X minus 2y, x plus y to the negative 1. Plus c.
Yeah, 2
Yes, squared, sorry. I forgot there was a square there. Yeah, so you don't have to do what I did here. If this didn't make any sense, don't do it. I just do that because very often when you're trying to integrate and it looks like there's more than one variable, it kind of sticks in your head. You can't really see what's going on. So you just pick a number for y. Do that. Come back. And now you're like, okay, I see how this works. Just throw the y's back in. I don't know if you guys are with me or not. You don't have to do it. You can just do this shit right. Yes?
Yeah, it would be.
Oh, there was already a negative out there, wasn't there?
Yeah.
Okay, thank you. Yeah. This minus carries. Yes. Okay. I was just too focused on that one piece. All right. I agree. That one was weird. But the thing to look for is, and I'm not overly concerned with these kind of integration problems that relies on you remembering these little weird side notes. This was a weird side note. Add, subtract, it becomes something, you know, that's not something we do every damn time. It's a little side note. But does it make sense, that approach? Okay. They may do that a different way? I'm curious. Okay. Anybody skip that one? So, remember this too. How do you show me, let's see, what problem was it on the practice test? Show me when a unique solution exists. I think it was was related to number 3. I made number 3 a little more concrete. Find a region in the xy plane where this would have a unique solution past their point. Here's blah, blah, blah. Right? That kind of problem? You look at what?
dy dx, which is f of x, y.
This will be f of x, y, and you see where that is
Continuous.
continuous. And you also check where
Partial derivative of
df
y.
dy is continuous. Yeah. So it's going to be a region where both of those are true, and it could be more than one region. You guys with me? So where is that continuous by itself? X, y to the 3/4. Where's that continuous? Or did the x have any problems? Nope. So it's cool with the x. So the first piece of the point could be any real number. What about the second piece of the point, the y's? And we try to keep things real. Can you imagine a differential equation? We will get some later. But can you imagine with complex numbers? But right now we're keeping things real, right?
Can't be negative.
Yeah, it can be negative, because there's a fourth root, right? It could be 0 though, correct?
Yes.
Okay, so right now, x could be any real number, y must live in 0 to infinity, including 0. Take a derivative, what's going to happen to the y piece? Because it's derivative partial with respect to y, correct? So what's going to happen to the y piece? It's essentially going to go down, because it's going to become y to the,
-4.
what's the power going to become after a derivative?
-1/4.
Negative 1/4. I don't give a shit about constants really right now, right? I'm not taking the derivative. I'm investigating what happens. The y goes down, so now can't be 0. So now it's open parenthesis on the 0, right? Can anyone tell me x could be anything? Y's got to be above 0. What quadrants can my point live in? 1 and 2. Not including the x-axis, but you can include the y-axis, correct? You guys see that? That's a beautiful way to answer that question. Just tell me, your point can live in these freaking quadrants. Leave me alone. Right? I want somebody right there. Right. Next problem. So that's the whole idea about the existence and uniqueness there. Anything else on this that gave you immediate issues when you looked at it? How about, did anyone try this? Did anyone try this?
Isn't it just the f prime?
Yeah, totally. There's a homework problem all about that. Did I talk about it in class? No, because I'm an asshole. But there was a homework problem about it. So homework plus me equals class, right? So could I ask you that question on the test? Yeah. Will I? No. It's just good to know. It's kind of cool. And if you didn't do the homework problem I'm talking about,
15 on 2 point
yeah.
something.
So this is dy dx equals a function of y, correct? So what would d squared y dx squared? What do you get when you take the derivative with respect to y of this? Isn't that chain rule? Would it be f prime of y times dy dx? So what's funny to me is technically there won't be inflection points if they make the slope 0. They would be constant functions then. But all inflection point means is does the concavity change from one side to the other? So I would include them, but the book says no. So really it's all about, like you said, it's all about where is the derivative of that function 0. That is not already a critical point for the first derivative. I don't know if you guys are with me or not. There's a homework problem about that. You need to do it for the homework. I'll just tell you right now, I'm not going to put that on the test, but I still want you to know it exists. You with me? And again, real quick, remember, I want to show you very quickly, how quickly could I do this? Oh crap, what is this? This will be y squared. No, it'll be y minus 3y plus 3, and what will there be 2 of? There will be 2y minus 3, I think, right? When you factor that, is that right? Critical points would be 3 and -3, so I do this. It's gonna turn around, it's gonna stay the same sign around 3, if you remember your multiplicity. So it's positive here, stays the same sign around 3, and then it changes sign around negative 3. What's it look like between negative 3 and 3? Can you guys draw it in the air? What's it look like? Yeah, there we go. I got one guy doing it. Somebody else doing some neat things. Looks like I'm trying to slide into third. Okay. You guys agree with me that somewhere in here there's an inflection point?
Yes.
That's all this is talking about, is where the hell would that inflection point be? So if you do it, if I remember correctly, I got it on the thing. I think it's -1 or something. Anyway, we'll see when I give it the key. So somewhere in between there will be a Y position that indicates where that inflection point is. You guys with me? And again, the whole idea of autonomous is, I know where things happen in terms of Y, but why don't I know X? Because it could just be shifted over as much as you want. It just repeats that same shape forever, depending on what the initial point is. Let me do this. Let me give you the answer key, so you guys can check and see if I got anything wrong. You're welcome. Oh, I'm gonna put it on.
Drawing physics shit?
This is really dependent on where you go after
Is
this
that
class.
1.3 with all the, they had retook physics problems or something?
Yeah.
That was 1.3.
Oh, yeah, he.
I'm very sorry, it's in my writing.
You make a good doctor.
Yeah, based on my handwriting alone. Pharmacists would think I'm a
It's funny
doctor.
because you're supposed to have like super stable hands, yet they can't write anything.
Yeah, trust me, I know. I worked at a urgent care for a long time. Okay, I don't think I like. Oh yeah, the very last one I didn't finish it because I just got tired. Really quickly on that number 5. I just was running out of room and it was I got to this point, and then you would just plug back in what u was. U was y to the -3. So then I could solve for y if I wanted to, right? I could divide both sides by x cubed, and then I could flip everything if I wanted to. I mean, this is the most I could really do with it. And then I could even, if I wanted to, I could divide top and bottom by x squared. It doesn't matter. Yeah. I'm not going to take points off if you stop here, but I will put a little note that that's not hard to at least get the y piece by itself, right? You know what I mean? So if you do that next step, y to the -3 equals x squared plus c over 3, I'd be happy, but you can do one more step at least and just flip it, right? I don't need a ton of simplification, just do simple simplifications when it's there.
Wait, what problem was this for?
5. I just sort of stopped on the answer key.
Oh.
Mostly because I ran out of room there.
Yeah.
Okay. I want to point out, real quick, number 4C. Where's my, here it is. 4C, I say, could also be homogeneous. Now, if you did this with the method for homogeneous or homogeneous, it would be gross, but you'll get the exact same answer. And the way I can see this as homogeneous is, can't I divide top and bottom of this by x, for example? Would it then be dy dx equals 1 minus y over x over 1 plus y over x? You see how that's homogeneous? It's in terms of y over x. You see what I'm saying? Would you want to do it as homogeneous? No. Homogeneous is one of those that most of the time it's going to be a bit of a variable. So if it's in some other form, you almost always will want to do that other form. I don't know if you guys are with me. Bernoulli's, you don't have a choice. Because That's the only thing that works when it's got that extra bit of y on it. You're like, damn it. Okay, maybe. So if we did the one problem, the only time you have a choice is if it happens to be autonomous, in which case it would be separable. Does that make sense? Maybe. Okay, maybe. By the way, guys, anytime I say something like this, you can say, no, it doesn't, Jeff. Can you try again, my friend? I think that's your whole job, right, Jeff, is to explain shit well. Oh, yeah. Start doing it. If you tried the practice test, were there any that were really difficult? They gave you a lot of trouble. How do you tell? So on the practice test, I was really mean. I just said solve, right? Part A, did everybody identify this? Separable, yeah, kick ass. What about this one? Linear, cool, because the y stuff is all to a first power. Your p of x is going to be tangent, so you got to remember what the integral of tangent is. And if you don't remember, you rewrite it as a ratio and you use u sub, right? Does everybody know what the integral of tangent is?
Negative natural log cosine.
Negative natural log cosine, or you bring the negative in, flip it, natural log of secant. That's the way I remember it, yeah. Secant, huh? Sure. And again, this is not something you have to memorize, but the integral of tangent is natural log, negative natural log of cosine. It is. Plus c. But you can bring the negative one up as a power, flip the cosine, it becomes secant, right? That's all. Not something you have to memorize.
Can I ask a question?
Yeah, of
On the
course.
Textbook things.
Sure, yeah.
It'll be 39 on 2.4.
All right, guys, I have a question from section 2.4, number 39. This first part, I like. And this is like, we did a concrete example. I started with a function much like this, and then we did a total derivative. And that's when I divided by x, and I said this is how to make it become not exact anymore. The integrating factor figures out what I divided by, blah, 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 blah. So is part A okay? And again, when I say it like that, I don't mean to make you feel bad if it isn't, right? Is part A okay? You just take a total derivative of this. It's going to become 0 for that, blah, blah, blah. So where did we lose it?
Part B. I just wasn't sure what it means by the same implicit solution.
Yeah, so if you plug 0, -2 in, do you get the same value for C as plugging a 1 in?
Yes.
Yeah, that would be the same implicit solution. You all agree that this is, does everybody understand this is an implicit solution, yes? Why is it implicit? Why is that an implicit solution? It's not solved for x or y. If I solve it, that's explicit. Right? Not gratuitous, but explicit. This is implicit because I don't know what y or x are. Okay. It's just implied they're functions of each other. Implicit. Okay, good. Is that right?
Yep.
So all it takes to be the same solution is have the same C. Yeah. And of course, multiple inputs for x and y could certainly come out with the same constant answer, right? Okay. Blah, 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 blah. Okay.
So what's an explicit solution? What's that?
Yeah, that's when I'm able to solve for x or y. Then it's explicit. Do you guys remember implicit differentiation? You remember that? That's when everybody really goes, well, I love this stuff. And then related rates makes you love it even more, but implicit is when we had to do, like y squared was 2y dy dx. It's the first time we had to do that. And the reason you had to do that is you can't solve it for y. So that's what we call implicit. It's implied that y is a function of x. I just don't know what the shit it is. That's why we call it implicit. Explicit is explicitly y equals function of y equals stuff. That's why why we call it explicit.
So then for C, you just figure out how to get the y by itself in the equation and then plug the stuff in to make sure it still works?
Yeah, once you figure out what the C is, you find, now, of course, if you try to find explicit solutions, interesting things are gonna happen, so, I don't know, depends on which way you wanna try to do that.
Okay.
Yeah. If you have any trouble, if you've already tried and you have no idea, then obviously you can ask me and I'll start as well. Yeah. Alright guys, so what's due on Thursday?
A test?
Is it due in the morning?
Yes, do that. So technically, if you needed to, you could finish the test, sit back down, finish something out and give it. Technically, it's supposed to help you get ready for the test, so you should be able to turn it in when you walk in the door, right? Does that mean if you're not done with something, you can't ever give it to me? I'll take late stuff, of course I will. If it's not that late, I might not even make it effective at all. I'm just trying to trick you to doing what you need to do to get ready for the test. I'm just telling you explicitly what I'm doing, right? No, it's what he said. You understand what's everything? Next week. Alright guys, oh, by the way, I'm not gonna be here tomorrow morning, but I'm hoping to be back by my 11 o'clock office hours, so.
Do you know how many questions are supposed to be on the test?
I have no idea.
I'm asking. Yeah, if I walk in and there's like 12 problems, I might mentally panic. But if I know there's 12 beforehand, I won't be so panicked.
Alright.
Oh wait, what? Oh, that's what you got.
Because I can't imagine he's
Oh,
doing
so
one
that's
for every
it.
section. He's probably combining like a couple concepts from
We do it in green.
maybe a couple sections into one, huh? That's what I would say.
So if you multiply everything by negative this is exactly the one.
And then yesterday I was ready to pick out a math, and then I was like, I saw on the Discord somebody said something about the test.
Yeah,
And I was
this,
like,
you did this together.
and that blew my mind. And literally, I was just trying myself away on the essay, right? And then I realized at the top of the essay, there was a dude who said the 27th, that's today. But I had scratched out very 29th because she amended it in class. So I was like, because nothing was due. But now, it's just really gross.
And it's hard to tell, it's much harder to tell how you're getting in getting a feel for it.
Yeah,
There's no real good
it's the
basis.
same thing with the, and that's why I struggle with Physics 202, because like, there's no basis for it. It's like, what the hell does 18,000 coulombs?
Yeah, it's not the same as like, you can't have a negative shed length. So obviously negative is wrong. No, you don't have that, yeah, you're right. Yeah, it's gross. Oh, the answer. Or the practice test.
Because he was simplifying this right here, and he got it to like y cubed.
Oh, yeah.
Even all my complaints. All I have left is so you can at least see the questions. But you got the answer.
Yeah, didn't do the judge.
Yeah.
And I was like, when are the test corrections? Grabbing my brain, like, how did he?
Everything's due the day of the test, except homework corrections. They're due the day of the final.